Plot a graph to show the variations of stopping potential, frequency of incident radiation in relation to photoelectric effects. See the graph here. See, this is the graph. Y-axis represents the stopping potential is V naught. The x-axis represents the frequency of incident radiation is V. If I take capital A, here V is greater than V naught. Not stop from the origin is the edge. Then I can say V is greater than V naught. Okay, that means the stopping potential at its overall really increases. As the frequency increases, stopping potential is also increases. Okay. Then, from Einstein's equation, we were using the Einstein photoelectric equation to show how from this graph with a short frequency and Planck's constant can be determined. Okay, from Einstein's equation, V is from Einstein equation, we know is equal to HP minus HB naught, where B naught is equal to H by T times B minus H by T times B naught. Okay, by comparing Y is equal to Mx plus C, then show frequency V naught is the intercept along the axis. Second one, it is the Planck's constant H is equal to Ex times slow. Second part here, how does one explain the emission of electrons from the photosensitive surface with the help of Einstein's photoelectric equation? Okay, we can explore that one. Like, when a photon of the energy Hb is observed by an electron in the photosensitive material, a part of the energy observed is used up, it forms the surface, it is a work function. The remaining energy appears as kinetic energy of the photoelectron. Second, what function of aluminum is a 4.2 repeat with the photons each of energy 8.5 or incident on its surface, if the emission of electron space is justify your answer. Emission of electrons would not take place because the energy Hb of a single photon is less than the work function, that is the phi naught. Then, third one. The stopping potential in an experiment on photoelectric effect is 1.5 volts. What is the maximum kinetic energy of the photoelectrons emitted? Calculate the joules. It is called C0. That is V0 is equal to 1.5 joules. Then Kmax is equal to E times V0. That is 1.6 into 10 to the power of minus 19 into 1.5. Giving the answer 2.4 into 10 to the power of minus 90 joules.